Hello students, welcome back to the lecture series of differentiation, and this is our lecture number 1, and in this lecture I am going to discuss about the differentiation method of composite function. That means I am going to discuss here how to differentiate a composite function, and let's go through the video. So this is use of chain rule, derivative of composite functions. Composite functions mean function inside another function, that is composite function, and we will discuss the composite function in the chapter function in details. So use of chain rule, how to use the chain rule in the process of differentiation, I am going to discuss about that. So here no extra method is there, just I am going to discuss some problems, and with the help of problem it will be clear how to differentiate a composite function. So let us take one question. So here find dy dx if the functions are given below this. The question number 1, y is equal to root over of 1 minus x square divided by 1 plus x square. So this is our given function. The question is to find dy dx, and actually you see, I am taking the pen here, okay. Actually you see, if we have y is equal to the primary function, root over function is simply y is equal to root x, and we have the formula in our first year classes that in this case dy dx will give us what? Dy dx will give us 1 by 2 root over x. It is simply 1 by 2 root over x. This is our formula for root over x. Here y is equal to, it is not given root over x, it is given root over of something other functions, not x. If it is y is equal to root over x, then it is the primary function, but this time in place of x you see it is 1 minus x square divided by 1 plus x square. So you should consider this whole terms inside the root over sign as x, as like this. So now the function is of the form y is equal to root of x, like this. So dy dx is equal to, first you use this formula by considering this whole terms as x. So it will be equal to 1 by 2 root x, mean this one. But here it was not actually x, that means the process of differentiation is not finished here, and then the chain rule comes here. So by the chain rule, now the term you are considering as x inside the primary function root should be differentiated again with respect to x. So this term is considering as x, therefore we are to take ddx of this term which you are considering as x, that is 1 minus x square divided by 1 plus x. Now you use the quotient rule in this part of the differentiation, okay. So you take that, I am erasing this, okay. So now I am using here the quotient rule. Quotient rule mean 1 by 2 root over this one, this term will go to the numerator, root over 1 plus x square, and the denominator will remain 2 into root over 1 minus x square into, now come here, ddx of this term, it is fx by gx format or u by v format, you can think about u by v. The process of quotient function, it is a quotient function, so the denominator is square, this is square, then the denominator into, denominator mean 1 plus x square into, now derivative of the numerator mean this part. So it is 1 is 0, then minus x square derivative is twice x, you know this, x to the power n format, so it is n into x to the power n minus 1 was the formula. Then this is compulsory minus for the quotient rule, then this time numerator into, numerator is this one 1 minus x square, so it is remaining same, into the derivative of denominator mean this one. So derivative ddx of 1 plus x square, ddx of 1 is 0, and plus x square derivative is simply twice x. So this is simply use of quotient rule, and you know the quotient rule. The quotient rule is u by v, it is this one. I am writing here. It is ddx of u by v. The formula for ddx of u by v will be is equal to v into u dash, then minus u into v dash. V dash means derivative of v divided by the denominator is v square. This is the formula. So in this case the denominator is 1 plus x square, so that is square, then denominator into mean v into, that is 1 plus x square into ddx of this, and it is simply minus twice x. This is compulsory minus this one, compulsory minus the numerator mean u into this one into ddx of the denominator mean twice x. So this is the differentiation of 1 minus x square divided by 1 plus x. Then just simplify it. It is simple. This is remaining same, and if after completion of this product it is minus twice x and here minus twice x will give us minus 4x, and it is minus 2x cube and here plus 2x cube will get cancelled. So only minus 4x will be the numerator here and denominator is remaining same. Now you see it is 1 plus x square whole to the power half and it is 1 plus x square whole square. So you can adjust these two. So it is nothing but this minus is coming outside, this 2 and 4 is cancelled with 2, x is remaining here, this term is same, and it is x to the power 1 plus x square whole square and 1 plus x square whole to the power half actually. So the power will be like this. This power is simply denominator power is 2, this base is same, so it is 2 minus half. So it will give us the power is 4 minus 1 is 3 by 2. It is 3 by 2, and we are taking the power of 1 plus x square is 3 by 2, and this completes the solution of the problem. Very simple, and usually these problems are not asked in your exam, but at the very first beginning you should know the process of differentiation of composite function being function of function. So I am taking actually some questions here just for recall your knowledge from the first year. Okay, so then you take another question, number 2, y is equal to sine square root over a square minus x square. So here the first function, which is the outer function, the outer function is sine, because sine square mean, you know this one, you see here, you see this is actually sine square x, it is actually sine x whole square, is not it? It is sine of x whole square. This is sine of x whole square. So what is the inner function? The inner function is sine x, this one, and outer function is the power. Okay, so here you see you have to find the derivative of first function is square, then square is on sine, so derivative of sine, and after that inside of sine. In that way you should use the sine rule. So first of all, therefore dy dx is equal to sine square derivative is 2 sine, this power will be decreased by 1, so sine of what? This one, into then what term you are considering as x? This time you are considering sine root over 1 a square minus x square is considering as x. So ddx of that term you are considering as x should be differentiated in chain, and then you complete the next line. This 2 sine is remaining same, then ddx of sine of this one. Now the outer function is sine x. So ddx of sine function is cos, this term is considering as x, so cos of x into ddx of, but this is actually not x, therefore ddx of this term considering as x mean root over a square minus x square. Then the next line will be this is remaining same, this is remaining same. Now ddx of some root over function. Root over what is the term inside it is not matter first. First you are to find the derivative of root over function. So derivative of root over function, I just told you in the previous screen that root over function derivative is 1 by 2 root over. So ddx of root over something is 1 by 2 root over this term. But this term is considering as x. So ddx of this term by chain, I am not writing here. So a square minus x square derivative is a square is 0 minus x square is twice x. That line is skipped here. Actually here it is the term ddx of a square minus x square, and that is written directly here. Okay, now just simplify it. It is very simple. This 2 and this 2 will be cancelled. Minus will come in front of all functions, and here you see 2 times of sine, it is like theta. So 2 times of sine theta into cos theta is equal to sine 2 theta. So you see equal to, this minus is coming outside, this x is here, 2 sine theta into cos theta is equal to sine 2 theta. So sine 2 theta is this one, divided by this 2 is cancelled out, and the term root over a square minus x square is present here, and this completes the solution of the problem. Okay, next you take another question. Y is equal to 10 of ax plus b whole to the power n. This time the outer function is what? This time the outer function is 10, because the term ax plus b whole to the power n is inside 10. But if it is 10 to the power n, then n will be the outer function, exponent will be the outer function. But this time 10 of the term to the power something is the inner function. This is the inner function. So outer function is 10. So you should consider it 10x like this. So y is equal to 10x, and the differentiation of 10x, formula of 10x was sec square x, you know that one. So dy dx is equal to sec square, this term total term is considering as x, so sec square x into ddx of the term considering x is ax plus b to the power n, so it is ax plus b to the power n. In the near future you should not write like this, you should write the total differentiation in one line only. Okay, but it is the very first class of differentiation, therefore I am writing in details. But in future I will not write like this, I will write the differentiation of these types of function in one line only. Okay, so here dy dx, first you are to differentiate 10 function, that is sec square, this is considering as x, so sec square x into ddx of this term is this one. Then the next line will be sec square is this is remaining same into ddx of it is something x to the power n format, x to the power n format. So the outer function this time is the exponent, therefore n into this is x to the power n minus 1 formula. X to the power n differentiation is n into x to the power n minus 1. So it is n into ax plus b is considering as x, so x to the power, this power is decreased by 1 into ddx of, again this term is considering as x, so ddx of ax plus b is simply a, because x differentiation is 1, so it is a, and b is ln constant, so derivative is 0. So this is the solution for the question. So you can write like this, this is a into n here, this term is written here, and sec square this is written here, and it completes the solution of the problem. And this is next question, y is equal to sec of 10 of root x, and this question is for homework. First here you just recognize the outer function. Which is the outer function? It is sec. This total 10 root x should be considered as x first time. So y is equal to sec x. So formula is ddx of sec x is equal to sec x into 10x. So that will be sec 10 root x into 10 root x into ddx of what? ddx of 10 root x. ddx of 10 root x. But ddx of 10 function is sec square. So it is sec square root x into ddx of this root x, and root x ddx is 1 by 2 root over x, and that will be the final result for this problem. And I think you can solve this problem. So next we proceed to the next question. Y is equal to cos x cube into sine square x to the power 5. So here actually product function, the first function is cos x cube, this is the first function, and sine square x to the power 5, this is the second function. So cos into sine. So here you are to apply the product rule of differentiation, and the product rule tells us differentiation of the first function into second function remaining same, then plus first function remaining same into differentiation of the second function. That was the rule for the product. So dy dx is equal to, so first function is what? Cos x cube. X cube is, you don't think about x cube, just cos. So ddx of cos function is minus sine, but it was x cube, so x cube is written as it is. So cos x cube derivative is minus sine x cube, but this is not x because primary function contains x here, but here it is x cube. So by chain rule you are to write the derivative of x cube also, and that is simply 3x square, x to the power n format. So n into x to the power n minus 1, this 3 will come out and the power is decreased by 1. So cos function derivative is minus sine x cube, and x cube derivative is 3x square. This is the derivative of cos x cube, and the second function means sine square x to the power 5 will remain same. By the product rule, plus is compulsory into, now the first function cos x cube is remaining same, into, now come here, sine square function derivative. So here outer function is the exponent square, so it is 2 times of sine power 1 decrease sine x to the power 5. Then into, you are considering sine as x, so sine function derivative is cos x to the power 5 into, now x to the power 5 is considering as x, and that derivative is 5x to the power 4. So just you write the simplified line, and that is simply 3x square, negative is here, 3x square sine x cube, sine square x to the power 5, then plus this is 5x to the power 4 cos x cube, and this is 2 sine theta into cos theta like, so it is sine twice x type. So this completes the solution of the problem. So this is the next question, y is equal to sine of cos of tan of x cube. So first outer function is sine, you are to write the derivative of sine considering this terms as x, then you are to write the derivative of cos considering this term as x, then you are to write the derivative of tan considering x cube as x, then you are to write the derivative of x cube, and that will complete the solution of the problem. So you see that line, so dy dx is equal to ddx of sine is cos, this total term is remaining same, into this is considering as x, so ddx of this term. The next line will be cos is remaining same, this one, into ddx of cos function is sine of this term is remaining same, into this is considering as x, therefore it is ddx of 10x cube. Okay, then the next line will be cos of this is remaining same, this minus is coming out, sine of this remaining same, into, now ddx of outer function is 10, so the derivative is sec square, you know that one, 10 function derivative is sec square. So sec square, this is x cube is already in the given question, so sec square x cube into this x cube is considering as x, so derivative of x cube is simply 3x square. That means the power will come out and the power is decreased by 1. So this is the completion of the solution. Okay, so you may write in simplified form, 3x square can be taken in front of all functions, you like this, so minus 3x square, then cos of this, and sine of this, sec square, this is the solution of the problem. Okay, so next you see y is equal to cosec x degree, and cosec function differentiation have the formula, cosec function differentiation formula is minus cosec x into cot x. That was the formula for cosec function, and cosec is written in computer CSC, and you should write in your book as COSEC, cosec x degree. Here one simple concept, x degree, actually differentiation is nothing but a result of limit. You know, differentiation is nothing but a result of particular limit. And what was the particular limit? The limit was limit h tends to 0 f of x plus h minus fx divided by h. This is the particular limit. So actually differentiation, all the differentiation, they are nothing but the results of that particular limit. And in the limit chapter, in first year classes, limit chapter, we know limit of trigonometric functions inside terms of trigonometry should be in radian, not in degree, because all the theorems of limits involving the trigonometric functions, and those should be in radian measure, not in degree measure. So therefore you cannot differentiate x degree directly. You should not write cosec x degree is equal to minus cosec x degree into cot x degree. That will be wrong, because this degree should be first convert into radian, and after radian you can find the differentiation. Okay, so for 1 mark these types of question usually are asked in your exam. So first of all, y is equal to cosec x degree is nothing but pi x by 180. You know that one, you see, because we know 180 degree, this is pi radian, then this is pi radian, then 1 degree pi by 180, and then x degree will be is equal to pi x by, it is pi x by 180. This is the cos. Okay, so first we have converted this degree measure in terms of radian measure. Then you write the differentiation. Now the formula of derivative will be applicable here. So therefore dy dx is equal to cosec function derivative is minus cosec, this total term is considering as x, so cosec x into cot x into ddx of pi by 180, pi x by 180. So pi by 180 is constant and x derivative is 1, and this is the result. And you may write like this, pi by 180, you may write here 1 degree also, so minus pi by 180 into cosec, this is x degree and this is also x degree, and that is the solution of the question. Then we take the next question, show that ddx of mod of fx is equal to this one. And here you should know that this differentiation is valid only when this denominator, mean mod of x, is not 0, because in the chapter continuity and differentiability, the previous chapter, mod function, it is not differentiable at the point where this inner function is equal to 0. That means you take one example here as like mod of say x minus 1, mod of x minus 1. This function is not differentiable at what? At x is equal to 1. And how we can obtain this? Because if x is equal to 1, then this entire term is equal to 0. Okay, so where the inside term of a modulus function is equal to 0, at those points the function can never be differentiable. Okay, so here I am not writing here fx is equal to not equal to 0, but it is actually you know that one, that mod of fx, it is not differentiable when fx is equal to 0. That is a different topic actually. Okay, so ddx of mod fx is obtained by this formula actually, and fx be any function, can be any function. So you prove it. So ddx of mod fx, and mod fx modulus makes a function positive, and it can be removed or it can be replaced by root over positive square root of fx whole square. You see, mod fx, it is obviously positive square root of fx whole square, because whole square will make fx as positive, and root over positive square root of square term will give us the modulus of or positive part of the function. That is why mod fx can be replaced by root over of fx whole square. Okay, so actually modulus function cannot be directly differentiable, and that is why we should make it in usual format. So ddx of this one, and it is equal to ddx of the outer function is root over, so it is 1 by 2 root over this one into this total term is considering as x, so x square is 2 times of x, and this fx derivative is f dash x. Okay, you try to understand the chain. First differentiation is root over x, that is 1 by 2 root over, the function is remaining same, into square function derivative is 2 times of the function, and it is 2 minus 1 is 1, need not to write here, so twice fx. Then fx is considering as x, therefore its derivative is simply written as f dash x, mean derivative, and that is equal to this 2 and 2 will cancelled out, fx into f dash x is the numerator, and this term is again be replaced by mod of fx. Okay, mod of fx. So this is this may be used as a formula for finding the derivative of any modulus function. So let me take one example for this. ddx of mod of sin x, you see, by this formula or theorem, it is fx into f dash x, that means sin x into derivative of sin x, f dash x means derivative of sin x, and that is cos x divided by mod sin x. Now you see this function mean mod of sin x is not differentiable at the points where sin x is equal to 0, and we all know the value of sin x is equal to 0 when x is 0, x is pi, 2 pi, 3 pi, minus 2 pi, and so on. That means when x is n pi, where n is an integer, at those points sine function is not differentiable. Okay, so this is y is equal to sin x function. This is sin x function, and we know the graph of the sin x function. It is very simple. It is a curve like this, wavy curve like this. This is the sin x function. 0, sin 0 is 0, then sin pi is again 0. This is minus 1. This is pi by 2 pi. This is 3 pi by 2, value is minus 1. 2 pi is again 0. 5 pi by 2 is positive 1. Then 3 pi is again 0. In the left side also like this. This is the graph of sine function, and you see in this graph there is no sharp turn of the graph. Therefore sin x function is differentiable at all points, mean it is differentiable in R. But in case if it is taken as mod sin x, then what will happen to this? You see this, y is equal to mod of sin x. Now mod sin x and sin x function is 0 at the point, you already know, at the point is 0, pi, 2 pi, 3 pi, at those points, and mod will make the function positive. That means no part of the sine graph will remain below the x-axis. You see the graph first, you see actually the graph of sine function was like this. This branch was actually here, this branch was actually here, but because of taking modulus sign, this lower part will be positive, and so it will go to the above the x-axis like this. Similarly, this part was actually in the lower part. This graph is actually like this. This one is like this, Okay, you may see the complete graph was like this. This part was there, this part is here, this part was there, but because of taking modulus sign, this red portion of the graph is going to the upper half or upper part of the x-axis. And you see here very sincerely that this at the point 0, pi, 2 pi, 3 pi, minus 2 pi, minus 3 pi, minus 4 pi, minus 5 pi, and so on, mean n pi, and where n is an integer. So at n pi points, at the points n pi, the sin x function can never be differentiable. And why it is not differentiable? Because if you observe the graph of the function, you will see that the points pi, 2 pi, 3 pi, at those points the graph of the function has a sharp turn. Is it clear? Okay, so modulus of fx function derivative is fx into f dash x divided by mod fx, and you should always keep in mind that mod of fx mean fx is 0, at those points the function cannot be differentiable. Okay, so you take the next one. This is y is equal to root over of 4 plus root over of 4 plus root over of 4 plus x square. This is simple function. So first you should differentiate this root over, then you should differentiate the inner part, then you should differentiate the inner part, and in this way the chain will progress. So dy dx is equal to, first of all, this root over. Whatever the terms inside the root over sign is not matter. So root over function, it is 1 by 2, root over is remaining same. d dx of this root over derivative is written, so these terms is considering as x. So d dx of those terms. Okay, the next line, it will remain same. d dx of 4 is 0 plus, and now the derivative of this root over sign. Okay, so you see here 1 by this term is remaining same into 4 is 0 plus is there. So d dx of this root over function is now, so it is 1 by 2 this term 4 plus 4 root x into d dx of, now these terms are considered as x. So d dx of those terms. Okay, now d dx of 4 will be again 0, in plus is plus, and this time you are to take the differentiate of this root over. So this is remaining same, this is remaining same into 4 is 0 derivative, and then root over function derivative is 1 by 2 root over that one, and this 4 plus x square is considering as x, so it is into 2x. 4 is 0 and x square derivative is 2x. Now just simplify it, this 2 will cancelled out, this 2 will cancelled out, numerator is only x, and this term, this denominator can be replaced by y. It can be replaced by y. Okay, so you write this one, numerator is x, one of the two is cancelled, so this 2 into 2 is 4, this term is this term is this, and this term is this. Now it is replaced by y. You may not replace, if you leave the answer here it will be okay. So it is 1 x by 4, this is y, and this term is actually from here y square minus 4, y square minus 4, and root over 4 minus 4 plus x square is remaining same, and this completes the solution of the problem. Okay, and then you see the next question, number 10. Y is equal to 5x by this one, it is cube root. Okay, cube root, and plus sine square of this. So dy dx is equal to, it is quotient function, so denominator square, cube root mean actually 1 minus x square whole to the power 1 by 3, so square of that is whole to the power 2 by 3. So denominator is square, then denominator into d dx of the 5x term is 5 only, minus now 5x into d dx of 1 minus x square whole to the power 1 by 3. So 1 by 3 will come out into 1 minus x square to the power 1 by 3 minus 1. It will give us minus 2 by 3 into this term derivative is, mean the term involving as x is 1 0 minus twice x. So this is the derivative of 5x by cube root of 1 minus x square. Then plus, here the outer function is square, so 2 times of sine function sine twice x plus 3 into, then the function is sine, so it is cos of 2x plus 3 into, then you are considering this term is x, so it is 2 only. Now simplify it, so it is 3 is taking LCM, 3 is taking LCM, which is 15, it is cube root, plus, because this minus is coming here, so plus 5 into this 2 is 10, and x into x is x square, and this negative power is written like this, and that 3 will come in the come into the denominator like this, plus 2 times of this 2 is here, and this is 2 times of sine theta into cos theta like this, so it is sine of 2 theta, that is sine of 2 into twice x plus 3 mean 4x plus 6. Okay, so next you take LCM, this one, this term is taken LCM. So taking this LCM, it is 15 into cube root mean whole to the power 1 by 3, and into 2 by 3, it is actually this term you see here, it is actually 1 minus x square, 1 minus x square, sorry, whole to the power 1 by 3 into 1 minus x square whole to the power 2 by 3 like this. If you take LCM this, if you take LCM this, then this into this, and the base are same, therefore 1 by 3 plus 2 by 3 is 3 by 3 mean 1. So it is 15 into 1 minus x square whole power 1 actually. So need not to write that one. Plus is here, this is 10x square simple, 3 is this, and this term will come to the denominator. So the power will be add up, 2 by 3 plus 2 by 3 is equal to 4 by 3. Then this plus sine of 4x plus 6, and this completes the solution of the problem. So I am erasing this. So next one, this one, simple, 15. This is 15 minus 15x square plus 10x square is minus 5x square. 3 into this one and this one, and this completes the solution of the problem. So this is one of the problem, y is equal to sine x square, sine square x, sine square x square. So first sine function derivative, simple, dy dx is equal to sine derivative. This is outer function is sine, so it is cos x square. Then this x square is considering as x, so it is twice x, plus sine square, outer function is square, so it is 2 sine x, into sine x is considering as x, therefore derivative is cos x, plus, so first outer function is square, so 2 sine x square, into then sine function derivative is cos x square, into this x square is considering as x, so it is twice x. Simplify it, so it is twice x cos x square, plus this is actually sine twice x because sine 2 sine theta into cos theta form, it is sine 2 theta, and then plus 2 sine x square into cos x square mean sine 2x square, and this twice x is here. Okay, so we finish this class here. So next day we will begin the chapter, I think differentiation of implicit function, and then differentiation of inverse trigonometric function. Very important chapters, those are very important chapters. So in the next day we will begin the chapter, we will finish the chapter differentiation of implicit function. Okay, so till then, thank you very much.